Hi everyone. So that was interesting, let's say. I really hate making templates. So just templated class templates. Uh, so the idea that we have here is I don't want to say exactly what's going into one of these classes, what kind of variables I'm going to have, or I can even make a templated function itself. So I've just been making templated classes or class templates, meaning I can stick in various things. The key thing that we're going to be looking at is that every time I make a new class template and I compile, I will make for every type of data that is being stored in that class, I will make a brand new set of classes. That's what's weird about this. And I'm thinking I have an overly convoluted example here. Lots of examples for you guys, but it's not helping make anything easier. I'm just glad I didn't try and live code this in front of you. So here is me making that same thing for a linked list. Okay, it's going to take some data type T. I'm not even trying to do the template of a template thing that I was planning on doing. So here's a linked list. It takes in data of type T. That doesn't mean it changes the nodes. It means the nodes themselves take in, here's linked list node. It should take in data of type T. Right? And I could put them on the same line. I could put them on separate lines. Depends on your style. Right? It is a templated class so that when I make a linked list node, it is storing data of type T. And everywhere where I had LL data before, I put T, saying what kind of data is it? Don't know, don't care, just some kind of data. Data object foo, right? I'm not being specific on purpose. When I go to compile the code, it will see what T requires or expects. Everywhere I use T, so let's see if I can find an example of me using T somewhere. That's not going to force T to be anything in particular. T get the data, but it doesn't really do anything. It's not like I thought printing the data would do something. Let me see here. Oh, there it is. Great. Data, get data. So I have an object of type T from class T, and I'm going to be calling get data on it, which means anything I'm storing in my linked list has to implement the function get data. That's it. So when I say data has a function called get data, anything I put in this class has to implement the function get data. That's what it's doing. If I have a function called set data, it has to implement that function. It tells you the requirements so that when you put something in there, it says, does it fit or not? So if I try and put in a type of data that does not have a function called get data, it will not work. It tells you the blueprint. This is the blueprint for the kind of data that's going to go in. And then when you actually try and put in that data, as long as it adheres to the blueprint, you're fine. It is a massive pain in the backside. Look at this. Every time I use T, I put in a T. I don't put in an actual data type. I put in like T. T is a sort of standard approach for us. I can get the next. Maybe what I should be doing in here. This is a node of that type. Let's see if that's going to break anything for me. I'm going to set the next value to a linked list node that also stores a value T. That's what that's saying. Let's make sure that actually works. It may not. Let's see. Hey, it actually worked. Good for me. Notice, let's do a linked list. Where is it now? DLL node. It is class. Here's the class. And it is extending linked list node again with a T. Every time I put the word LL node, essentially, I might be overdoing it. I don't know. Just because I don't make templated objects all the time or class templates all the time. But effectively, every time I say linked list node, I put a T. Every time I say DLL node, I put a T. Right? Every time I'm using a DLL node, every time I say the class, I put that template in there. I say, and it's going to take data of that format. So including, it's going to extend linked list node type T, T, T. Everywhere it's going to be that same T everywhere. So if I'm printing data, here's my data T. Notice I need the function get data. If I don't have get data, T is not acceptable in here. And I could have just said that instead. No, I got the data. I get the data from this class. Oh, okay, that's fine. Here's me getting the previous. Again, it's templated. Nothing has actually changed in my code, by the way, if you hadn't noticed. I had a DLL node beforehand. I have a DLL node with a template in there. It's essentially every single one of them get tagged this little T, saying, by the way, I'm going to store some kind of data in there. The key is, at least the way I'm implementing it, and I'm sure there's probably other ways, but this is how I've always implemented templates. It's all in the header file, which means if you have any mistakes in your header file, it's bad. So hopefully maybe we can demonstrate this, because I didn't want to demonstrate that live. It's a big pain. Oh, it handled it better than I thought it would. I was getting errors where I'd make a small little mistake and I'd get, 50 errors. And every single time I made any change, I had to recompile everything all over again. That's why we don't normally stuff everything in our header file. It's a pain. But in this case, we need to do it. Everything has to be there all at one place. I can't distribute it over multiple files like I did last time. If I do, I can't generate these classes. The idea here is when I go to compile this thing, what's going to happen is every time I make a, let's say this is a DLL node, every time I make a new DLL node with a different type of data, I will generate a whole other class. Instead of this T everywhere, I'll be plopping down the actual thing it's being stored. So if it's storing, let's say, a string, fine. Well, string doesn't have get data, but let's pretend. If I try something else, it's fine. It'll take this, as long as it implements the different functions it needs, it's fine. My linked list has to also be templated because the DLL node is templated. If I don't know what the DLL node type is, I can't make a linked list that takes in that kind of data. Heck, even the iterator is templated with the same T. I need to know what the node is. Unfortunately, I still want to work around a workaround of that. But essentially, as long as I pass in a node and I can make my iterator, so I pass in the this is just the starting node that I'm going to be pointing to. I'm not happy with this particular chunk of code. But here's get. I just get the data. What kind of data? I don't know. I'll figure it out later. Unlike last time where I said it has to be LL data, it's just something, some kind of data. Notice I need set data. The data has a set data function as well. As long as I have set data and get data, I'm fine. Okay, so let's see, what else do I have? I can do the same. My code has not changed at all. In fact, this is literally, let me jump over to one of these. Let's do linked list iterator. I'm already in linked list iterator right now. Let's look at linked list iterator.cpp. What happened here? I just commented out all of my code. This is literally all the code I had in linked list iterator. I didn't do anything new. I just copied this over to here. I just swapped out, instead of distributing in two places, I just put the function definitions in the header file. I did not make any real changes to my code, at least initially. And then when I templated it, I kept on putting the kind of data in here. So instead of linked list data here, I put T over and over and over again. So let's have a quick look at what we have here. So let's run this and see what happens. What the heck? Why does it keep on saying stupid test, stupid test, stupid test, stupid test? I wonder what's going on. Oh wait. Sorry, I shouldn't play ignorant on things. Here's my linked list data. It takes in an integer, right? That's the kind of data it takes in. So it's a class. It stores data in the form of an integer. I can set the data, and that sets whatever the value is, and I can get the data which returns that value. Here's a really stupid example. Here is a brand new class called LLData2, because that's original. And every time I set the data, I just set the data to stupid test. The string, the data itself is a string, because why not? I could have said stupid data 1, 2, or use that number. That would have also been fine. And when I go to get the data, I just return a string. This is returning a string. It's also taking in an integer, but that's fine. But get data is returning something different than the other get data. But they both have functions called get data. They both have functions called set data. And in fact, if I go back to my main method over here, here's my main method. Where is this? There we go. All I did was, I think, was the other one called 1, or is it just left off? I think it's slipped. Okay, and insert at the back. So all those set datas are fine. There's something weird going on here. No, LL data is fine. Okay. And then I need to just change some stuff around. This is going to store LL, oh, because this thing here. Instead of taking in a bunch of linked list data 2s, it takes in linked list data. And I'm going to change 2 more. The iterator is going to be changing. And that might be almost do it. Oh, I'm getting the data itself for this loop that I had before. That's not new. And there. So everywhere I went from linked list to linked list data 2 to linked list, linked list data. Oop-a-doo. I had to make a whole other set of classes. All of my classes got redefined, recompiled. It generated classes so that it's storing, instead of storing a linked list data 2, it's now storing a linked list data. That's what happened in there. So I could have a combination of these things. That's no problem. Here's my original code again. All I did was say the type of data we're storing is different. It's not a linked list data 2, it's a linked list data, and everything just works. That's why we have templated classes. What we're going to see when we deal with standard template libraries is that you can do the same thing. I can sort an array of anything I want, or linked list of whatever I want, as long as I have some kind of iterator, some way of walking down this data structure and some way of ordering it. I can store anything, and my same sorting algorithm, the way to rearrange everything, is going to be the same. I don't have to change, I don't have to write new code. I don't have to make a sorting algorithm for integers and a sorting algorithm for floats and a sorting algorithm for strings. I just need to know, can I compare them? And can I walk down my array or walk down whatever data structure is storing this? That's what we're going to be dealing with very, very soon. So let me take a quick pause, and then we'll get to the actual slides themselves just to remind you what's going on here. And then afterwards, we'll go on to bigger, badder things. Thanks, everyone.